This is IAT 806, Lecture 10, and what we're going to talk about in this lecture is PImage and PFont, which are methods of accessing images from image files you might have, also for accessing the pixels on the screen and doing something with them. And the PFont is about dealing with reading fonts in and drawing text in your processing window using whatever font you specify. So let's get started. So our basic outline today is about programming concepts. This is really focused on how-to within the processing environment. And we're going to use two classes. PImage is the image class within processing. P, of course, stands for processing. And PFont is the font class, which specifies a font which subsequent calls to text enable you to draw. So to load images, one of the things that processing enables you to do is to do a very simple call to load an image from an image file. But one of the things you have to make sure to do is, given that you've got a project, the processing directory, wherever it is that you've set it up for yourself, there's a folder in there called Sketchbook, and within that is the name of your sketch or your processing program. Within that, you can put image files that you're going to load. You can also put them in a data subfolder that you can make. So you can use the data subfolder for all sorts of data files, be they, comma separated values, image files, font files, all sorts of things that can be put there so that your program can find them. The other thing that will be in this file under project name, whatever your project name is called, I'll show an example in a bit. You could also see that there are PDE files, which are processing files. That's the actual source code for your processing program. So that's where to put those files so that, when you run this code down here, it actually does something, finds an image file and displays it. To actually read an image off the, out of the file system and then have it available within your processing code, what you need to do is to declare an image, a PImage variable name, in this case IM, you can call it whatever you like, and then have equals load image, and then that's the image file name. You just need the file name of the image, not the the full path, just the file name if you've put it in the right place. You can, of course, I think also put the full path if you really feel like it, but it's just easier to stick all the files that go together in the same folder. When you zip up that folder and then send it to us as, TA or prof, having all the files together in the same spot is, really, really valuable. And if you make us really search for image files, then, you're kind of asking for trouble. So this is one of the reasons why processing has this kind of elaborate setup and requirement to put things in particular spots, is to enable that to become a package very easily and for you to ship it to somewhere else. They unzip it and they can run the same thing that you have. So to display images, you just simply make a very simple, just like other processing calls, a call image. And what you do is the first argument is an instance of the image class that you have access to. And remember, on the previous slide, I declared IM, right, to be of type PImage, the PImage class, and I did load image, which loaded the image from the disk and stuck it in that reference variable IM. So image IM says use that image, and 00 is the location of the upper left corner of the image. So that will display your image from the previous slide I showed in the top left of the window if I didn't have anything else going on, say in the draw function, or if I just did that in setup. So probably one of the things you want to do in addition to drawing images is you'd like to access pixels. But so the only drawback, or the only kind of challenge that you have to confront when dealing with processing images, is that processing stores the pixel data in a contiguous array and a one-dimensional array. So we're going to talk about how to access data within this one-dimensional array such that it makes sense for a two-dimensional image. So the PImage class allows you to access RGB values in each individual pixel of the image with the pixels array from the image. You can get the width and the height of the image in the file by accessing the width and height fields of PImage. So you say im.width, im.height in order to access those two pieces of information. And that'll give you the information you need because the number of pixels equals width times height. Okay, so that's essentially the starting point of how to access files. Now let's figure out how to compute the proper address in this one-dimensional array. So here we have an image that's 5 pixels across by 4 pixels down. And, so there's 20 pixels in this thing. The only thing is, as I said, the pixels array is one-dimensional. It's a single array with one, single index in it. So what we need to do is to learn what it means by which we store pixels in one order. And so the way it works in processing and in many other image formats is pixels are addressed starting at the top left to be 0, 0 and stored in rows. So the first row is here, second row, third row, fourth row. And this is a common way of addressing two-dimensional or higher dimensional really, but two-dimensional data collections in a one-dimensional array. You come up with some kind of algorithm to transform the pair of numbers for x and y into a single index. So let's show how that's done. So I've just moved it slightly. So the first row of pixels, 0, 1, 2, 3, 4 at y equals 0 are stored in the first 5 elements of the array. So index 0 is at location 0, pixel 1, 0, 1 is at 1, pixel 2 is at 2, etc. The next row is stored contiguously right after that. So that's where row 2 is, 5, 6, 7, 8, 9. So basically what that does is it takes the row index, which is based at 0, multiplies that by the width and adds the x index in order to get the proper location. So because this is one row down, that's 1 times width. The width is 5, right? 5 plus this index being 0 gives you 5 for this guy. If I wanted y equals 1, x equals 4, that's 1 times 5 plus 4, giving you 9. And so on for the rest of these things. There's 10 through 14 and 15 through 20 here, 15 through 19, indicating the indices that, and where they are stored. I'm kind of reusing orange here, but the idea is basically that the array of pixels stores this stuff row by row. So to figure out what the computation is, I already verbalized it, but the way the array index works is it's the x index plus the y index times the width. And of course, you can get the width from the PImage field. So, im.width will tell you what that is. So if you said, as I said before, if you want y equals 4, x equals 0, x equals 4, y equals 0, sorry, I got that reversed, then that's located here, and that's 4, x is 4, and y is 0. 4 plus 0 times 5 equals 4. If I want this one right here, that's, row 3, column 3, row number 2, and that's 3, 2, or 3 plus 2 times 5 equals 13, and that's that one. And you can see that's 5, 10, 0, 5, 10, 11, 12, 13. So anyway, that's basically how to do this accessing. Take a look at the way in which the slide does the addressing. Sometimes I'm trying to talk too fast and I fumble the order of the numbers here, but that's the way in which that works. It's x, comma, y, just as in many other argument lists that you would see in many of our in all of the graphics calls. X comes first, y comes second. Okay, so what would it look like? What piece of code would you need to get color from a pixel? So here's a snippet of code that does that. This is a thing you could run without setup or draw. So PImage im equals load image, some image that we have. And if you were to copy and paste this, make sure that I'll make sure that the double quotes are proper here. These are 6699 quotes that are not equal to the double quote character for strings. Color C1 equals im.pixels, and then the index 3 plus 2 times im.width. That gets the color at x equals 3, y equals 2. And color, in fact, behind the scenes, that's a processing type. It's a processing fundamental type, but really what it is behind the scenes is an unsigned 32-bit integer, which has been carefully packed to fit the 8-bit red, 8-bit green, 8-bit blue, and 8-bit alpha, meaning transparency. For the images that we've seen here, transparency is usually 255, meaning fully opaque. But in any case, you can use that to specify a color. You can just shove the C1 that we've got here, that is a color type, into calls that ask for color as a parameter. So stroke C1 uses the color that you've picked out of that particular pixel as the stroke color for further calls. And so I'll show applications of this as we move forward in the lecture today. So one of the things that you're probably aware of course, is that the window that you're drawing in is also an array of pixels. And in fact, it has a pixels array. But if you wanted to have your code access the current state of the drawing area, what its pixel values are at some particular moment, what you have to do is make a call to load pixels. And what this does is it goes to the rectangular screen area that contains all the pixels of the current drawing area and loads them into this kind of magic pixels array that processing has. You need to call load pixels because you need to actually activate the function to go and copy the pixels from the frame buffer, the drawing, the displayed area, and into the pixels array. It doesn't do it. It requires you to actually activate that call to call load pixels, because otherwise, if you really wanted live, then your processing program would constantly be automatically loading pixels from the frame buffer into this pixels array, and that would result in absolutely terrible interactive performance. So really what you want to do is you want to call load pixels, say, one time, maybe at the top of the draw method or at the end of the draw method, and then in the next iteration you can you have the pixels array loaded with the previous the state of the draw window at the end of the previous draw, and then you can start doing things with that image. In any case, load pixels is the thing that you call that loads the pixels, surprise, surprise, into the pixels array, and then you can start investigating inside the pixels array the state of the drawing area at the moment that you called load pixels. You don't actually need a separate PImage object. Pixels behind the scenes is likely an alias, so to speak, for a PImage object that processing is just creating for you and making ready for you to access with a minimal amount of text. So here it is. Here's the example. Load pixels, that loads the drawing area, and then color C2 equals pixels 3 plus 2 times width, and that gives us the color at pixel x equals 3, y equals 2 in the window, somewhere in the upper left corner of the drawing area. So why would you want to use both of these? Well, you'd use the Windows pixels if you want to draw more things based on the image that's already there on the screen. One of the things that can be kind of effective in terms of drawing is to accomplish a kind of evolving image that continually redraws itself. And one of the things that can be pretty effective is if you're selective about where that drawing is being slowly overwritten and updated in some parts of the screen, and perhaps elsewhere you're constantly drawing new things. It will be up to you whatever kind of thing that you would like to draw. You would use the images pixels if you want to manipulate the pixels of the image before you draw them. So, a couple of usage scenarios. One of the things is picking the stuff off the window in order to update it and, perhaps write it back to the screen. Use the images pixels if you want to manipulate the pixels of the image before you draw it. And what I mean by that is, let's say, you have a picture of my face coming right up, then, you wanted to, make the background area of my portrait or something like that blue. You'd do image processing or something in order to find the background, and then you change all the color of that to blue, and then you do, image IM at the location that you wanted, and then you have me on a blue background. Or you on a blue background. It's up to you how you do it. As you already know, we've dealt with arrays a lot. We talked about it in the previous lecture and in lots of prior lectures. Java also has the capability of making arrays of arrays, also called 2D arrays or two-dimensional arrays. You can make 3D arrays and 4D arrays also. These are very useful for accessing arrays of pixels like the ones we've been working with. So here's a couple of examples of 2D arrays, and int 2 square brackets, open close square brackets in a row, and Bob is the name of the 2D array we're creating, and then we would say new int the x size and the y size, and that would create something of an integer array, or approximately similar to the tiny little image that we showed earlier on in the slides. Here we have another one, color square brackets, pixels 2D equals new color 200 by 200, and what that means is that's going to end up being used as a two-dimensional array. Interestingly, behind the scenes, 2D arrays are just covering up, kind of reconstituting a one-dimensional array, just like the pixels array does. So behind the scenes, Java is implementing this 2D array thing as a one-dimensional array in which it's computing an index on the basis of x and y values. So these two things that I'm showing here are equivalent to each other, except of course the machinery of addressing is a little bit different. They do the same thing. The 2D array convention makes it just simply easier for us to address the array based on things like our x and y values, and it's a convenience, and computing an array index from two separate values, it's laborious. So it's creating a two-dimensional array is a lot easier. So now that we've talked at length about PImage, what I'd like to do now is to talk about PFont. The P is not silent. So PFont is the processing class for manipulating fonts, and it's similar in that it's a processing class, and has a similar kind of role as PImage for images. It's for processing, it's within the processing system, and there are some ease of access things that enable things to be done quickly. So you use PFont by once again declaring a variable and of PFont type, and then you load a font. And what that means is going to the font library that processing has, grabbing a font file that you've set up in advance, and I'll show how that works, loading it into a font, and then you can do, once you've done that and you've set the font, you can then, all text drawing that takes place after you've set the font uses that font. If you set font to a different font, all text after that setting uses the second font. So it's just like setting color. It's a mode. You set the color to green, stuff gets drawn green until you change the color to blue or whatever it is. So PFont load font, but basically what that's saying is that load font returns a PFont that goes off and gets a file out of the file system, constructs the object, and hands you a reference to the object. And so the way that to draw it is you to set the font to be active, you call text font with the font you want, and you can specify its size, just essentially its X height or something like that. And that sets the current font, and then you say text with some string, its X and Y location, and that draws a string using whatever the current font is. You could also use float X and Y values for that. And it draws a string at the current, at the XY location that you specify. So here's a simple little example. Basically what this does is it loads a couple of fonts that, I've kind of worked out already in the processing system just now, and draws two copies of the word on the little drawing window. So what I'll do now is I'll just go to the processing system and show how that works. Okay, so here is the processing window, and in Tools, there's this option to create font. So let's just click on that, and you have a vast list of fonts to choose from. These come from all over the place. They're built into Windows, whatever it is. So I want Garamond Pro Bold. That's what that looks like. That's what that looks like. Just keep clicking around and I get different fonts. Now, I can set the size by default. It's kind of valuable to set a larger size, and then you could shrink the size, set a smaller size when you want to draw it. If you set a small size and then expand, let's say you selected a 12-point font and then you wanted it to be 100 points, 6 or 7 times larger in your drawing area, the resulting font will look a bit pixelated. So if you want it to be smooth the way it was designed, choose a large one, and what that does is it creates a font that is essentially a suite of polygonal outlines that is then drawn as a suite of polygons. So that's what's going on behind the scenes. That's what enables the font thing to work within the drawing machinery of processing, is that these things are really resolving themselves to lists of polygons, a polygon for F, a polygon for G, etc., etc. A complex polygon for F, for each of the letters. So you select the size you want. I will just stick with 48 here, and you say OK. And what that will do is it will create a font file of that size in your processing window. Now I just wanted to do that to show you how to do it. It's straightforward stuff. I've already done that with this Engravers 48 and this Snap 48. So now I'm just going to press play, and you can see that there is, the Engravers version of it and the Snap ITC version of Word. And, they take up a different amount of space, they have a different appearance, and so on and so forth. And all I've done here is said text font ENGR, for short for Engravers, right? So that was the PFont variable. That's the type. And load font loads the file and sticks it in creates essentially a new font, a new PFont object, and ENGR is pointing at it. Same for Snap. Set the text font to be ENGR size 22, a little bit smaller, and then I do Word at 1030, and then set the font to be Snap at 22. Again, do the same thing, except it's 1060, so it's a little bit lower. I can set the size to be 44. For one of them, let's just do the one in the interest of time. And, I get bigger letters. Okay, so very straightforward thing. Let's now go back to the slides. And so very simple example. And, you could run that in sort of scripting mode, right? You don't need to have setup or anything in order to do that. I could use fill to change the color, so let's just do that. We'll go to, once again, to the processing thing, and what I will do is I'll just set fill here. Zero 255 0. And I'll set the fill for this next one to be 255 00, like the slide says. And we'll press play. And once again, we will get, the same words, except the first one is green in Engravers, and this one in Snap ITC is now red. Funky looking font. Okay, so just a quick demo of, how that stuff works. So the other thing that you can do with this is you can set the alignment, text align left, right, or center. What that means is, how it interprets the X and Y value when you draw text. X, Y is in the upper left, and that's kind of the default. X, Y is in the upper right if you set text align right, and text align center centers it. And so the point that you specify is where the center of the chunk of text is going to be. The other thing is that because these things behind the scenes end up being polygons, all the transformation methods, scale, rotate, etc., translate, apply to drawing text. You can translate, rotate, scale text, etc., etc. Combined with draw, that means you can move this the screen around, the text around the screen in real time. And just like, rockets and asteroids, it's just another piece of geometry that can be moved around inside the scene using translate, rotate, push matrix, pop matrix, the entire package. It's just, chunks of text act the same way because underneath the covers, they're just polygons that are being drawn by the graphical system. And, that means you can do things like having text move around like, like it's any other kind of graphic object. So here what I'm going to do is I'm going to show a longer example of, a chunk of code. And basically what this thing does is it combines loading of an image. So PImage IM again, and I do a load image, and it's going to be a picture of me. And you can actually copy and paste this one because that's got the correct double quotes. Use your own image when you do yours. And what this thing does is at setup, it just draws the image of me a bunch of times from xy equals 600, 600, all the way down to 0, 0, and you will see that very briefly. And then it loads the two fonts here and sets the text font to be the engraver's one. And then in draw, it draws me, again, draws my image, mouse X plus this to account for the fact that, the size is fairly large. Picks off, a pixel, a color, does load pixels, sets C1 to be the color. And so here we're doing this accessing the color value from the pixel array, sets the stroke to be that, the fill to be that color, text align left, draws an ellipse somewhere special, you'll see where, sets the text font to be engraver and says yo. And then sets a different fill color, draws yo again, and rotates it. So we'll see how that does its thing. So hold on a minute while I copy and paste. Okay, so there's the code, right? So there's the image, the variable for the PImage, the two variables for the PFont. It loads the image. And what I'm going to do is I'm going to change the name to be, intentionally misspelled draw. And so we'll run that and we'll see how that goes. Okay, so let's just run it. And what we see there is you see me show up, and this is a picture from a number of years ago, you may have noticed. But I did have a receding hairline, so I took this while I was in grad school, and I smiled. Same smile, but as you can tell, less gray hair. Anyway, what that's done is that, as you can see in the image, I've got a picture of me drawn down here, then up here, then here, then here, then here, then here. And the reason why I went in reverse order from 600, 600, up to 0, 0 is because I wanted the last one to overdraw all the other ones and for it to be visible and be comprehensible as a portrait or something, as opposed to just, kind of a top left corner of something weird. So anyway, all that did is just draw those things and loaded those two fonts. I haven't done any font drawing. So let me go back and stop this and, unmisspell draw, and then we'll get what this thing is supposed to do. And here it is. And so what this is doing is, sort of moving around the red yo, and that's the second one in the code, right? That rotates a little bit and picks up the mouse value. And this other one is drawing the ellipse right on the tip of my nose. It took me a little bit of time to figure out where my nose was. And it's picking off the color at 3, 2. And so when I finally move my hair underneath this, I get a different color of yo, and it shows it as black. So anyway, yeah, different colors there. And the reason why this is working is what it's doing is it's grabbing the entire image array, picking off a color in the upper left-hand corner, and so most of the time it's white. And this is kind of getting at, I'm not clearing the screen at any time, I'm just simply overdrawing, 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 and you can see these interesting kind of smearing effects. It's kind of fun. Okay, so let's go back to the slides now. So that's essentially what that program does. You can put your own code in, your own image, your own fonts, and get it slightly different. And if you're interested in working with images, having some fun with, taking an image and doing something with it, dragging, grabbing a whole bunch of images and doing some fun things with it. So there was some interest among you for how to do that kind of stuff, and so there it is. So okay, that wraps it up for PFont and PImage, and I hope when you have the chance, you get a chance to enjoy using those techniques for your own code.